Salam and good day everyone. Hi, my name is Vivian Isol. So this is our video presentation for AGR668 Plantation Crop Mechanization from class M380 to 2068. So this project is entitled Farm Mechanization Plan for 500 hectare for rubber plantation, and it focuses on how mechanized operations can improve efficiency, reduce labor dependency, and support sustainable practices in rubber industry. Before that, I would like to introduce our group members. Me, myself, Vivian Isol, followed by Jivet Christian Johnny, bin Nurfati Najwa bin Pawatang, Muhammad Is Irfan bin Muhammad Nazri, and Muhammad Azim bin Alimi. So, for introduction, rubber has long supported Malaysia's economy, but production is declining due to low prices, aging trees, and shrinking workforce. Other than that, rubber tapping is still manual and labor intensive, which needs skilled labor, while some mechanization exists like tractor for land preparation and sprayers for weed control. Adoption of machines remains low because of high costs, uneven land sizes, and limited farmer training. So, to improve rubber farming and solve labor problems, we need to understand these challenges and find better ways to modernize the farm. To understand more of farm mechanization plan for 500 hectare for rubber plantation, I will pass to the next presenter. Thank you.
Hi, my name is Yvette Christian Johnny. Now I'm going to identification the operation that we need. There's two operation, which is operation A and operation B. Operation A is land preparation. We use the plugging and harrowing tractor. We do land preparation before or after replanting rubber. Next is operation B is weed control. We use the mounted spray boom because it more fast and efficient. We do this for periodic maintenance. That's all.
Assalamualaikum to our beloved lecturer, which is Dr. Amir. And first of all, my name is Muhammad Izifan bin Muhammad Nazri, and my matrix number is 2023-149851. So for this slide, I will explain section 2.2, which is making assumption. In any field operation, we need to make some basic assumption. This may help us estimate how much work can be done, how long it will take, and what resources are needed. First, the total land area we are working on is 500 hectare. The second one is the number of work days available is divided into two parts. The first one is 30 days for land preparation, which is include plowing and harrowing. The second one is 5 days for spraying or weed control. For the third one, we assume that each working day consists of 8 hours. These assumptions are important because they help us plan manpower, schedule activities properly, and make sure the project is achievable within the available time.
For this part of study, we focus on determine machinery capacity for land preparation. One complete land preparation involves plugging and harrowing. The tractor used has a field efficiency of 75% and it operates 8 hours per day. To calculate the EFC, we use the formula speed multiplied by implement width and multiplied by field efficiency, then divide by 10, which is 5 times 2 times 0.75 and divide by 10, we get 0.75 hectare per hour. Now we calculate the daily capacity. 0.75 hectare per hour multiply 8 working hours equals to 6 hectare per day per tractor. To cover 500 hectare with 2 passes, the total workload becomes 1000 hectare. So the total numbers of days need by one tractor is 1000 divide 6 hectares per day equals to 166.7 days. To meet a 30 days project timeline, we divide it by 30, which equals around 5.5 tractors or practically 6 tractors. This calculation shows that 6 tractors are required to complete the land preparation within 1 month, ensure the efficient of time and resources. Now we move to Operation B, which involves the use of bomb sprayers for field operation conducted 4 times a year. The key parameters for this operation are an 80% tractor efficiency, 12 meter boom width, and an operating speed of 6 km per hour. The field efficiency is also set at 80% or 0.8. Using the same formula for effective field capacity, we multiply 6 multiply by 12 multiply by 0.8 and divide by 10 equals to 5.76 hectares per hour. For daily performance, we calculate 5.76 hectare per hour multiply 8 hours per day equals to 46.08 hectares per day. Given the total area to be covered is 500 hectares, the number of days required for one unit is 500 multiplied by 46.08 equals to 10.8 days. However, if we aim to complete the task in just 5 days, we divide 10.8 by 5 and we get the result in 2.2 sprayers unit, which we round up to 3 sprayers. So, to ensure timely and efficient weed control over 500 hectares in 5 days, 3 bomb sprayers are needed. This ensures both productivity and enhance the spraying schedules.
Now, after the calculation, I will determining the number and size of machine tractor. For the operation A, which is land preparation, we need 6 tractor with 90 horsepower and 2.0 meter for the width. Operation B, which is weed control, we need 3 tractor with 50 horsepower and the implement width is 12 meter.
Assalamualaikum and good day to everyone. Myself, P. Nurfatin Najwa binti Pawatang, and I'll be explaining the cost analysis. For the cost analysis, we begin with fixed costs. The total machinery cost is 476,000 ringgit, which we depreciate over 10 years, giving an annual depreciation of 47,600 ringgit. In terms of operating costs, the main component are fuel, calculated at 270,000 ringgit annually, and maintenance at 5% of total machinery cost, or 23,800 ringgit. This gives us a total yearly operating cost of 293,800 ringgit. When combined the depreciation, the total annual cost comes to 341,400 ringgit. If we spread this over 500 hectare, the cost per hectare per year is 682 ringgit 80 cent. For long-term planning, machines are scheduled to be replaced after 10 years. Regular maintenance and optimized usage help to reduce unnecessary costs, and reserve fund will be set aside yearly to support future capital needs. Finally, when we compare it to outsourcing, which costs 500 per hectare annually, we find the break-even point for investing in machinery is just under 2 years, specifically around 1.9 years. That's all from me. Thank you.
Okay, so for the conclusion, this study highlights the urgent need for mechanization in Malaysia's rubber industry, which currently face low productivity, labor dependency, and limited adoption of modern technology. Focus on land preparation and weed control, the research shows that using 6 tractors and 3 boom sprayers over a 500 hectare area is highly cost effective, with an estimate 682 ringgit 80 cents per hectare annually and break-even point in less than 2 years. However, smallholders still face major challenges such as high initial costs and lack of technical skills, which limit the widespread adoption. While tapping remains a manual process due to precision required, other tasks like spraying and field prep can be mechanized efficiently. To ensure the long-term sustainability, national policies must support technical training, equipment sharing scheme, and stronger collaboration between the government, the Malaysian Rubber Board, and academic institutions. This will help modernize the industry and secure better returns, especially for smallholders. Thank you.